Okay, guys, let's go through the second video here. Okay, so the rest of today's lesson, we're not going to do really any graphs today, but we're going to talk about converting from one form to the other. Okay, so a couple formulas that you just have to memorize and actually we can draw it out. Let me do this. I should do this and make a lot more sense. So if we just draw a right triangle, right? If we draw a right triangle like this, okay, and I make that my theta, and this is my r, and I do the default x and y, right? Well, okay, from Pythagorean theorem, x squared plus y squared is going to equal r squared. So we have that relationship, right? That's going to be true. And then if we take the cosine of theta, well, cosine is equal to adjacent over hypotenuse. So cosine of theta is going to be x over r. Another way of rewriting that is that x is equal to r cosine theta. Okay? And then the same thing for y. Why don't I just write that? So the cosine of theta is going to equal x over r. The sine of theta is going to equal y over r. Now, obviously, we're taking a quadrant one view of this, but if we extended this angle around more, we would still have the same relationship. We would just draw a triangle in a different place. Okay, so these two cosine and sine relationships, if we just want to isolate for x and y, we get this, and we know from Pythagorean theorem that x squared plus y squared is equal to r squared. Okay, so those are some relationships that we should know. And in these examples, maybe you want to try and do these first. I'm going to put up the blank notes. I know it's late, but if you want to practice them, how can we convert this to a rectangular point? And how can we convert this also into a rectangular point? So remember, this is our radius. This is our theta. And so we got to remember our unit circle, right? Cosine of pi over 3, sine pi over 3. Same thing here, right? What's the cosine of negative pi over 4? What's the sine of negative pi over 4? So that's going to be really helpful for us in converting those. If you want to just look at my answers, so here's what I've got. You can check me. Hopefully this is right. Cosine pi over 3 that should be root 3 over 2. So, sorry, cosine of pi over 3 is a half. The sine of pi over 3 is root 3 over 2. So 5 times cosine of that is 5 over 2. And then 5 times the sine of pi over 3 is root 3 over 2. The way I think about it, right, pi over 3 is higher up than pi over 6. This is pi over 6. This is pi over 3. So that means pi over 3 has a smaller cosine. We're only moving a little bit to the right. We're moving a half to the right, and we're moving root 3 over 2 up. So the cosine of pi over 3 is going to be half. The sine of pi over 3 is going to be root 3 over 2. Now I've got a negative on both. Okay? So I want to draw this out, right? Negative 3, negative pi over 4. Well, negative pi over 4 would be down here. Negative 3 would push it there. So it's really the same thing as 3 pi over 4, right? It's the same thing. 3 pi over 4 is here, positive 3 is there. So now I just know cosine and sine. So the cosine, that's going to be negative root 2 over 2. The sine of 3 pi over 4 is going to be root 2 over 2. So there's my point. One other relationship that we have, right, is that, and it's a little bit tricky because it depends on the quadrant, but if x, y, if that coordinate is in either the first or the fourth quadrant, then theta is going to equal the arctan of y over x. And if you guys remember, arctan, right, that's only defined in quadrants 4 and 1 for that reason. Okay, so if we take the arctan, we're going to get the first or fourth quadrant angle. If xy is in the second or third quadrant, right, and we can tell from, just drawing it out, but theta will be the arctan of the quotient y over x plus pi, right? Because if we're in quadrant 1 and tangent's positive, we add pi to get to quadrant 3. If we're in quadrant 4 and tangent's negative, we add pi to get to quadrant 2. Okay, so this is a little bit trickier. I kind of prefer to just draw it out. So yeah, like a couple examples here. Sorry guys, I was just worried I didn't do something earlier. Couple examples here. Okay, -2, -2√3. And guys, what we want to remember is, right, we're going to start to see this a lot, but this is really the same as √3/2 and 1/2 here. So when we see this √3 and not anything else, you can think 30, 60, 90. Okay, it's a good little trick to remember. So if we draw this point, -2 left, -2√3 down, right? I know this is my bigger side length, so that's going to be 60 degrees. Here's my 30, here's my 90. Okay, so I've got a 1/2 √3/2 and 2 or 1 relationship. So this side, it gets doubled. I know my hypotenuse is 4. And yeah, I'm just checking that everything works. So -2 squared is 4. -2√3 squared is 4 times 3, which is 12. So that makes sense here. If we want to give this as a polar coordinate, it's going to be 4 pi over 3, right? Pi over 3 is the same thing as 60. So that's the angle, and that's the radius. Okay? Maybe just think about this one. 1/2 -√3/2. That's kind of nice because those are unit circle ratios. And we know the radius is going to be 1. Okay, so I'm going to draw it. 1/2 -√3/2. I'm down in quadrant 4. I know, again, this is 60 degrees. And so if I want a polar, that's going to be 300 degrees. And 300, I believe, is 5 pi over 3. So yeah, that would be the angle. And the hypotenuse of the triangle, or the radius, is going to be 1. Okay, last thing. Be ready, guys. Okay, this is going to get a little bit, how to say it? It's just a little complex. To use a terrible, it's a terrible pun. But so we have this complex. I don't know if you guys have learned these before, but you definitely will do it a lot more if you take an IB course next year. If you take AP Calc AB, you won't do complex numbers at all. You might see it in BC, but not in AB, okay? And AP Stat, obviously, you won't see it. But we have a complex number. It has a real and an imaginary component, okay? You guys actually probably saw these with quadratics, okay? But we haven't touched them too much. But yeah, so we denote that as Z, A plus IB, or A plus BI, right? This is the imaginary component. This is the real component. Another way to write that is, instead of A and B, we have R cosine theta and R sine theta, right? So we can think of cosine theta, you know, when we're taking cosine is the adjacent side, and sine is the opposite side. So, you know, you could think of cosine as like the X value and sine as the Y value. So another way to write this complex formula, or complex number, excuse me, is take the radius out, and you have the cosine theta, which is the X component, plus the I sine theta, which is the Y component. Okay, and you'll see this a lot. And then the tangent is just, yeah, you can find the angle by taking the arctan of B over A. Okay, so we just want to write these values in that are in trig form to standard form, okay? And it's going to be a unit circle exercise, guys. So maybe you want to just pause and work through all this. Hopefully remember cosine of 30. It's going to be √3/2. That's a half. This is going to be -√2/2. This is positive √2/2. Right, 5 pi over 3, that's going to be 1/2, sorry, cosine of that, and then sine of that, it's going to be -√3/2. Okay, so we just write all these values out. I just realized now, I I don't have my I component here, so I need to put an I in right there for the imaginary part. Sorry about that, guys. Okay. And now here we've got to write them in polar form. So we need to get, it's kind of annoying. We need to get an angle and we need to get a radius. And for most of these angles, we're going to have to use a calculator, right? So if I draw this out, right, I got, actually this one was okay, right? This is going to be, because we have this root 3, this is like root 3 over 2, this is 1/2. So this is 30, this is 60. Across from 30 is, you know, that's the smallest side. The hypotenuse is going to be double that. And if this is 30, we know it's pi over 6. So however you want to see that, this value becomes 8 comma pi over 6 in polar form. Here we've got, you know, the same side length. So this is going to be 45, 45, 90. If that's 45, that's like pi over 4. So this is like 5 pi over 4. And then if we have these two side lengths, right, we take root 2. You guys memorize this 45, 45, 90 triangle, whatever these smaller side lengths is, the hypotenuse is going to be that side length times root 2. So this is 7 root 2, 5 pi over 4. And then the last one, yeah, we have a kind of a hidden root 3 over 2 and a 1/2 here, okay? So the 9 root 3 over 4, that's going to be across from the 60. The regular negative 9 over 4 is going to be across from the 30. This is going to be double that, so that's going to be 18 over 4, so that's our radius. And if this is 60, this total angle is 2 pi over 3. So hopefully that makes sense, but this becomes 18 pi over 4, 2 pi over 3. Okay, so I know that's kind of heavy. This last thing is having you go into this same notation and just figuring it. But yeah, this is the one, sorry, this is the one where you're going to have to use a calculator. Okay, so if we start with 18 plus 3i, well, that's going to be in quadrant 1, right? Because we're going right 18 up 3, right? Right 18 up 3. That's easy. Now determine the radius. Okay, well, we just have to take the square root of 18 plus 3 squared is 9. That, I think, is going to be 333, so that's our radius, right? The square root of 333. What's the angle? Well, we have to take the arctan of 3 over 18, which is 0.165 radians. Okay, so we get this really messy root 333 cosine 0.165 plus I sine 0.165 cis form, right, of the number. Really prefer this 18 plus 3 root I, but this is the same thing. Here's a second one. So maybe you want to pause it. Z equals 1 minus 9i. So now we're going right and down. So we'll be in quadrant 4. And we're going to have to take the arctan of negative 1 over 9. Okay, so just if you want to try and work that out before you see what I got, feel free to. Okay, so the radius is going to be square root of 10. $81. That's not right, guys. The radius is going to be 81 plus 1, so it's root 82. Yeah. Yeah, I don't know why I have 10 there. Sorry, I forgot to square the 9. So let's just change that. That's root 82. The theta is still okay. We still want the arctan of negative 9 over 1. But yeah, this needs to be root 82. Sorry for that. Okay, and you know, you think about it. If we're going right 1 unit, down 9. Maybe I should draw this out. If I go right 1, down 9. To connect that, yeah, I've got to have a value a little bit bigger than 9, right? So that's going to be the square root of 82. Okay. This one looks okay. 10 squared plus 2 squared is 104, so that's going to be our radius. We take the arctan of negative 2/10, right? Because we're in quadrant 2, guys. So that's going to be 2.944 radians. So we have to adjust for that. And so then our expression will be square root of 104 cosine 2.944 plus I sine 2.944. Yeah, I don't know if I explained it here, but when we get this negative 1.46, right, I want a positive angle here. So I'm going to take that, I'm going to add 2 pi to it. So 4.823, that's in the same location as negative 1.46. I hope that makes sense. If I draw that out over here, right, negative 1.46 is maybe like that, you know, but we want to get to it by going around. So 4.823, that would be this positive distance here. And if that's negative 1.46, I make it positive and I add, I get 6.28 about, right? Roughly 2 pi radians. Okay, and the last one, negative 5 minus I, right? So we're going to move left and down. We're in quadrant 3. The radius is going to be the square root of 26, right? And then take the arctan of that. Yeah, I did that here, and I added pi because I wanted to go in quadrant 3. So I got 3.339. That's in. Boom, that is it, guys. I know that's a lot, but we'll have some time to talk about it in class, and we're going to move on to graphs when I see you guys very soon. So hope this is helpful. Hope you guys had a good break. See you soon.